All right. Hello, hello. We are going to work through some of our group work. So first we are finding the biggest angles in each of these shapes. So in the first one, it's a little hard to tell, but I think it's this one, and I can check that. In this one, this is the biggest, and in this one, this is the biggest. So if I take my protractor or even just think about it, I can tell that all of the angles in this first triangle are less than 90. So those are acute. In the next triangle over, this looks like a corner angle, and if I use my protractor to measure it, it actually does come out to 90 degrees, and we know 90-degree angles are right angles. In my last one, if I think about a 90-degree angle with this, I can see that we got that extra part there. It's bigger than 90 degrees, so this is an obtuse angle. These are the three types of angles that can occur in a triangle. All the other angles are all less than 90 degrees, so they are acute. So triangles always have two acute angles plus a third angle. If the third angle is acute, it's going to look like A. If the third angle is right, it's going to look like B. If the third angle is obtuse, it's going to look something like C. So those are your three choices for angle types. So you want to go ahead, open up a new page in your notebook, label it triangle names and properties, then add a section that says names by angles, and you can draw those three triangles at the top there, label them acute, right, obtuse. Make sure you show that we're looking at the biggest angle in each of those for the name. And you can pause this here and jot that down. All right, so we can also name triangles based on their side length. So all three of these triangles had different side lengths. Like if this was 3 centimeters, this was maybe 4 centimeters, this was maybe 4.5. Triangles where all three sides are different lengths are called scalene. Can you sketch a triangle with two sides the same length and a third different? How about this? And we'll make this one long. Maybe this is 5, and this is 2. So yes, I can. How about all three the same? Yep, we'll declare these. Oh my goodness. All three, those are all the same. So just like we used the right angle box to show 90 degrees, we can use tick marks to show side lengths are the same. So this is a shape with 90-degree corners and all four sides the same length. That's a square. This one also has 90-degree corners, but this side and this side are the same. They're maybe both 7 centimeters. And this side are the same, but they're different lengths because it's 2 tick marks. So maybe those are both 2 centimeters. That's a rectangle. So tick marks show sides are the same. If the number of tick marks is different, the side lengths are different. And this is a notation just like the boxes mean 90-degree angles. So you're again on that same page or a different page, if you already used it up, are going to add another section of names by side length, and you're going to sketch these. Make sure again you've got those tick marks on there. One quick note is if there's no tick marks, all three sides are different. Some people like to go 1 tick mark, 2 tick mark, 3 tick marks to show that as well. Equally valid, both the same, all good. All right, if you haven't paused to take those notes, do that now. All right, we're gonna look at one final thing. So your teammate took those 3 triangles from the front and they cut off the corners. So you can see that F here matches here, E matches here, D matches here. And they noticed that as they arranged those corners, they got a straight angle. These 3 made a straight angle. These 3 made a straight angle. Even with that 90 degrees, formed a straight angle. We know from yesterday that straight angles always add up to 180 degrees. So it doesn't matter what type of triangle. It can be acute, obtuse, or right. It doesn't matter about the side lengths. They can be scalene, isosceles, or equilateral. You will always have those inside corners, those interior angles add up to 180 degrees. So the last thing we're going to put in our notes is the triangle sum theorem, because we're talking about triangles. Sum means add. Theorem is just like a math idea. And we're going to write down that the interior angles of a triangle always add up to 180 degrees. And if you want to go ahead and add a little picture, I'm just taking that last triangle. I know that angle M plus N plus L will equal 180. So pause and get that jotted down. And then these last two you can also put in your notes. All right, again, pause at any point, but I'm going to get started. So I see 3 angles, and I know those 3 angles are going to add up to 180 because this is a triangle. So now I've got an equation that I want to solve for x. I know 45 plus 30 is 75. I can then subtract 75 from both sides to get x alone. And I get that x is 105 degrees. Now I can go ahead and solve for this one. So I know this angle, which is 90, plus this angle, which is 2x, plus this angle, which is x minus 4, also equals 180. I'm going to combine my like terms. So 90 minus 4 is going to be 86. 2x plus x is going to be 3x. Now that I've got all my like terms combined, I'm going to get x alone, so I'm going to subtract 86 from both sides. That gets me 3x equals 94 degrees, and I'm going to divide by 3. Now in this case, 94 divided by 3 is not going to be a nice whole number like 10, so I can leave my answer as a fraction like this. If I type this into my calculator, it is going to give me 31.333333 like that, which is 31.3 repeating. And that bar over the top says that 3 goes on forever. So either of those answers are, again, totally fine, equal points on a test or quiz, but that is my 2x values.